Good morning or afternoon or whatever it is. Welcome again to Humke's Study. Today I thought I'd take a look at the chain rule. So the formula for the chain rule, if you remember, happens like this. That if you have a composition, F composed with G of T, and you want to take the derivative of this, this is F prime of G of T times G prime of T. This formula, which you learned in Calc 1, also holds for multivariable functions in an identical way. But there are a couple of differences. First one is that multiplication. This, in multivariable case, is going to be a matrix multiplication. And the other one is these two. What is the meaning of derivative in higher dimensions? So let's take a look at this. And we'll do a setup, and then I'll do some examples to show how this stuff works. So the basic setup is this. We've got a function g that takes some space to some space, and then we have a function f that carries it further. So, for example, this might be the real numbers, and this might be the plane, and this might be the real numbers again. So an example of this happened to us in the practice exam, when G was equal to ohms travel. So ohm, I'll use R of T for ohm. R of T in this case, I think, was T squared 4T. So this function R takes real numbers and maps it into ordered pairs. So you're mapping R maps R into R2. F, on the other hand, was our temperature function. I'll change it a little bit. Let's change it to x squared plus 4y squared, just to make it a little simpler. And so the temperature function was here, and it took ordered pairs and mapped to real numbers. So now let's see what we've got here. We've got a couple of derivatives with the chain rule. So we want to look at the temperature of ohm. Temperature of ohm. So the function we want to look at is the temperature composed with ohm. This will be a function of T, and this function maps the reals to the reals. So this is a Calc 1 type function, one that you can deal with, but the plane is intermediate here. So let's just see what this is. We'll get a formula for this. So T composed with R of T means T of R of T. So first of all, we compute R of T, and that's the ordered pair T squared 4T. And then we plug that in to the formula for temperature. So we square the first components and add it to 4 times the second component squared. So this is 4 times the first component squared, so 4t to the 4th, plus 4 times 4t squared. Well, 4t squared is 16t squared. So this whole thing is 64t squared. So this is the formula that we're talking about. And I'll put it up here somewhere. T composed with R of T is equal to 4t to the 4th plus 64t squared. We're going to be interested in taking the derivative of that. T composed with r prime of t. And you can, this is just a calculus formula. So 16t cubed plus 128t. I messed it up on the first version of this video, but I'm not going to tell anybody. But anyway, this is the derivative. And now I'd like to show you how the chain rule works. So I'm going to erase all of this. Maybe I'll put the formulas up here. R of t is t squared 4t. And the temperature, T of x and y, is x squared plus 4y squared. So let's erase everything except those formulas. And I'll put up the chain rule here. T composed with r prime of t, which we already computed. This will be equal to t prime of r of t times r prime of t. So what I want to compute is these things now. We computed the left-hand side, or what's above, here. But now we want to compute the other side. So t prime of x and y. We already know how to do this. This is the total derivative. It consists of two partial derivatives because you've got two variables. And so if we take the derivative with respect to x, t sub x, this is the derivative. So we will get 2x and 8y. So this is a simple one, but I wanted it simple to begin with. Then r prime of t is equal to t squared 4t. But in general, what we will do is we will write this as a column. So t squared 4t. This was actually the formula for r of t. We want the derivative, so the derivative would be 2t and then 4. So here is the derivative of r, of our space curve. Here is the derivative of our temperature function. Let's see how it works. So now I want to plug into this formula. T prime of r of t times r prime of t equals, and the first thing is t prime, which consists of 2x and 8y, but we don't use the variables x and y. We sub in what r of t is. R of t is t squared, so that will be 2 times t squared. And then 4t gets plugged in, 4t for the y, so that would be 32t. So we get this 1 row, 2 column matrix that multiplies r prime of t. Now r prime of t is 2t4. If I wrote it as a row, the book does this, then you can look at this as a dot product. But in general, I'd like you to look at it as a matrix product, 1 row, 1 column. And so when we do this, we get 2t squared times 2t is 4t cubed. And 32t times 4 is 128t. And this is how it works. Hopefully we got the same thing. We didn't get the same thing. We should have gotten 4t cubed. We should have gotten 16t cubed. What happened here? So we got 2t and, oh, I see. When I took 2x, I got 2t squared and 2t, 4t cubed.